thank you for coming to the session. Appreciate you've got lots of options to go elsewhere, learn about Kubernetes, CICD. Today we're going to talk about getting started with Terraform. So hopefully you're in the right room. If you're not, feel free to move to where you should be. Just a quick show of hands actually. Who's used Terraform before? Okay, so there's a few of you. Okay, so this could be very much a primer to get into how you use Terraform, especially around infrastructure. My name's Lorenzo Galelli. I work for Inos, Enterprise Cloud. And you may be thinking, Inos, who are they? You're probably aware of Inos or one-on-one with domain names, web hosting, etc. as well. But last year we formed with another company called ProfitBricks, who provide infrastructure as a service. So we're now selling that in the UK, but also in other regions around providing infrastructure services built on public cloud. So we'll be using that really as a method with the Terraform, driving that forward as well. Okay. Quick look at the agenda. So I'm going to go through some of the infrastructure challenges that customers that I've talked to have seen, and really where Terraform comes in or automation comes in to overcome some of those challenges. And then really sort of talk about how this DevOps thing really helps in that type of process, really. We're going to use Terraform and putting that to work, and I'll give you a live demonstration as well by showing you how we actually build, let's say, a WordPress environment for production as well as QA test, etc. as well. Okay, everyone okay? Set expectation, nothing else that you want to see, or is that a good grounding? Cool. Okay, so infrastructure challenges, and I was trying to think of what graphic I could showcase. I think Brexit is a prime example. Yeah, so it's not something that we've been through before. We don't really know what we should be doing. There's no rule book on what should actually happen. So very much as you start moving to the cloud, really, what do you need to do? What do you need to put in place for automation, for consistency, and get over some of the challenges that you see? So things about consistent deployment challenges. So how do you actually spin out infrastructure in the cloud and use that on a continual basis and have a predictive method of spinning out environments and have them the same type of footprint and configuration as you use them going forward as well. That also sort of, I guess, entrenches into things like collaboration between teams. So coming from an on-prem environment where you have your networks team, your storage team, maybe your compute, is really how you try to extract some of those layers and have more of a collaborative approach as you spin out infrastructure into the cloud to use that and really sort of get the application teams talking very closely with the infrastructure teams and going forward that way as well. Change management is really key as you start moving to the cloud. So as you spin out new versions of applications, how do you track those? Making sure they're used, so you need some type of versioning control for that. And then lastly, documentation is obviously key. We need to keep on top of documentation. Any changes need to be added into the environment so you can track those changes and find out what actually happens on previous iterations of the infrastructure itself. So this really leads me, I guess, towards using DevOps as the principle of DevOps, really. And for that, really talk about CAMs. So CAMs, just a quick show of hands, who's heard of CAMs and applies that to DevOps? So CAMs, the term itself was coined back in 2010. There was a DevOps day in Mountain View where some of the main leaders, I guess, around DevOps, like Damon Edwards as well as John Willis, coined this phrase of CAMs. It's around collaboration, the automation aspects, and then you measure and then you share the relevant experiences that you have in relation to developing code and presenting that in the infrastructure. The culture bit is really important because it's around breaking down the barriers across the silos inside an organization. So the likes of your network teams, your storage team, getting them talking more collaboratively, and the same with the application owners as well. And typically, I'm sure you've come across it where you've wanted to deploy something, and it's just taken ages to get maybe a network IP address for an application, so you can stand that up and really test the application in your environment. So it's really around breaking that down. Automation is really the next key point. For me, what I've seen is automation more of a process where management have used that to work out what the cost is per operator in relation to what they're producing. But automation is around removing some of the barriers. Automate as much as you can, removing the levels of human intervention for providing code and providing applications and services into the environment itself. And that's really what we're going to focus a lot on around automation and providing things like the tool sets like Terraform. There are other tool sets out there, the likes of CloudFormation. You can obviously bring in the likes of Puppet Chef, Ansible, all the relevant tool sets out there. But with Terraform, it's coming to a point now where it can be used across different types of infrastructure. It doesn't necessarily need to use on our platform. It could be AWS, it could be Azure, it could be other platforms that you can use it for, and also other applications. So look at things like Kubernetes. You can use Terraform to deploy your clusters and then interact with Kubernetes at that level as well. So applying the DevOps principles of automation, we're looking to automate all things, or really automate as much as we possibly can, utilizing code to do that. Keep a track of things like version control. So as you produce new applications or new versions for applications, you track those, and then utilize that for deploying rollouts for your applications and organizations going forward as well. Leverage things like CICD, so continuous integration and deployment or development, so the likes of Jenkins, using GitHub, and really automate the whole flow of the infrastructure code out into the environment itself. And I'll show a sort of example of what that could look like. And then lastly, utilize infrastructure as code. As I mentioned before, we use Terraform for this example, but it could be other tool sets. But Terraform really has the benefit you can use it across any type of platform, really. Lots of pluggable modules which you can bring in and then spin out the relevant infrastructure or applications that you're looking to develop and produce. So what is Terraform? Terraform is open source. It's under the Mozilla public license 2.0. It was originally created by HashiCorp, who produced technologies such as Vagrant, Consul, Packer, and Vault as well. So a very good heritage behind it. Started way back in 2014, so we're now around about 5 years in its current iteration. It's written in Go, so it's extremely light. It's a single binary, which you can deploy down onto various platforms and then produce out the relevant infrastructure as a code going forward as well. As I mentioned before, it's pluggable, so there's loads of provider plugins, modules which you can attach into it and then utilize that for the various applications or infrastructure that you're looking to spin out into the environment itself. So what's the goal? So the goal itself is provide a tool which allows you to build, to change a build if required for things like version control, and also deploy out into your infrastructure, whatever that infrastructure build could be. So we have there the example of all-in-one INOS. We can obviously go to Oracle, OpenStack, VMware, AWS, Azure, Alibaba. So there's loads of different plugins which you can utilize with Terraform, depending on what provider you're currently using today. Terraform itself, basically what you do is you create the TF files or TF extension files, which are very basic type variable set, which I'll show you as well. Those are fed into the Terraform. As you build out, you create a state file. The state file is then used in JSON format to determine really what you've built out, and you can then use that going forward for maybe passing those variables out into the likes of Kubernetes to spin out a Kubernetes cluster, etc. as well. And we'll go into some of these as we build out into the demo as well. So putting Terraform to work, sorry. So we're ensuring creation and consistency. Previously before, you may have gone through, you may have got the basic build of an operating system. You may have deployed some packages in there. There may be some new packages you put in there. And really have a way of actually documenting that. Is either going to the usual TextPad, WordPad, or whatever, and get the relevant information, how you actually build a system from scratch. Where with Terraform, you can then utilize that as a documentation set to actually build out your applications or infrastructure. It leverages an API, very much agnostics in relation to how it speaks the relevant languages for those providers. And you can also apply incremental changes as well. So if you've got a new system you want to bring into your application set, it's quite easy to add that into the Terraform configuration. And as you apply and build out, just that single application or stack gets built into your environment. So it's not a destroy everything, recreate. It will just add, increment the relevant systems that you're trying to change in that environment. You can also utilize it to destroy as well if you want to. So you could go where you've got a version control, new version, spin out the new version, destroy the old version. That way you can leverage the whole CICD type flow or life cycle of the application and management as well. Have the ability to also preview the relevant changes. So as you apply Terraform, create a plan, and that way you can see what relevant changes are going to be incorporated when you run the relevant updates for your Terraform scripts that you've created. And scale is very easy to scale as well. So you can add in a number of nodes, determine how many systems that you want to provide, and then utilize a script to push out an environment based on your specification and design as well. So how do we get started? So initially, download Terraform. Go to terraform.io. You have the ability to download whatever platform is available. All the usual popular platforms are there, such as Mac, Linux, Windows. Once you've downloaded the various version, you can then obviously run the relevant commands. So here's some examples of the commands which you can run with Terraform. And we'll go through some of these in relation to how we build out the environment itself. Typical ones will be the likes of plan. So we're going to generate and show an execution plan. So as you create your configuration, you could use Terraform plan, and it will tell you exactly what it's going to build based on your configuration variables that you've set. Once that's done, we use Terraform apply to apply those configuration values that then applies and builds out the environment based on, again, on your specification. And we'll run through that with the demonstration which we've got as well. An example of providers. So in Terraform.io, you can go to docs. In docs, there's a provider section. Here I'm showing the ProfitBricks provider. As I mentioned before, 1&1 INOS uses the ProfitBricks infrastructure as a service. But there are things like AWS in there, Azure, or whichever provider that you're currently using. The important bit here under the provider is the data sources. And this is where we use the declarations of what we're trying to build with Terraform itself. So Terraform is a declarative language. So just be aware of that this is what you want the state to be. And as you run it, you'll see the state which will come out during that configuration. So here the data sources such as data center. An example there, you'll have the data center name, the location or region where the data center is going to be deployed, possibly a description as well in relation to the data center build. And then you've got other elements such as an image you want to use or location. And then further down, we'll use some of the things like the server, volume, or network as well. And we'll delve a bit deeper into these resources and how those are used. Okay. Any questions so far? Okay. So as I mentioned, Terraform, basically what you create these TF configuration files. What I normally do is I create a variables file initially where I'll declare various values or variables that I want to use in my Terraform script. So these could be things like passwords or usernames or consoles. And then in the main configuration file, I'll also declare some additional variables based on what I want to build. So that could be the CPU type that I want to use, be it AMD or Intel, CPU quantity based on what type of applications being spun out, which could be WordPress. So I may want to use 4 CPUs and a number of gigs of RAM. And I'll declare those as variables. So I can then quite easily modify those for the likes of QA tests when I want to have less values in relation to maybe a test or dev environment which I'm building. So here we're doing the same. We've got a variable. It's called PB user. This is the description for it, and this is the default value for that PB user. So as I use that in the Terraform script, you'll see a declaration of that variable and its use in relation to the key value. Okay, so in the main TF file which I'm creating, I'm going to specify that I'm going to use the provider profit bricks, so it knows which module that I need to pull down to utilize. So that could be provider AWS, it could be provider whichever the provider is that you're using. Username and password for this provider is my PB user and PB password, which is from the variables configuration file. And now I'm specifying my location in relation to where this infrastructure is going to be built out. So it's going to be in the UK, in the London Heathrow data center. I'm going to use image alias for the default value for the CentOS latest. So I'll use that as I build out my system, which will use the latest version of CentOS based on the image library inside the IONOS Enterprise Cloud. Passing a name server variable out as well, so I can use that to specify maybe a default gateway. So if I create a Bastion server, which we'll use as a jump, it will know where its default gateway is going to go, and then I can use that for any NAT resolves for any internal systems that are being created as well. Again, some more variables being declared in relation to the key path for the private keys as well as public keys. Okay. So I think the huge benefit of Terraform, it's quite easy to be read and for us humans to understand it, where if I look at other languages, it can be quite difficult and it can take you quite a long time to understand, the structure and how the actual scripting works. With this, it's quite straightforward, really. So we'll start off by creating the data center and going through the various key values which are declared. So the first one, we're going to create a virtual data center. We're going to use the resource Profit Bricks data center. So that's that resource that we saw on the documentation page. So we're going to give that a name of WebDB 01 dev, the location in that declared value of London, UK, and then it's going to give it a description if required as well. So we've got a data center logical container there and declared. And then we're going to create some networks. So now we want two networks. We've got a public LAN and we have a private LAN. So here we're using the resource Profit Bricks LAN. So it's defining the various VLANs in relation to the creation of the infrastructure that I want to create. It's going to be public, so we'll have a public IP associated with that, so any traffic can go out via the public network. And on the private, we're just going to declare that as a false for the public, so it's an internal network that we're going to be creating. So straight away in my head, I can see visually a container for the data center, and I can see two networks in relation to where traffic can go for that. And then lastly, I'm going to request also a public IP block. Okay, so this is a static public IP address, which will then be associated for any external traffic. And typically what I would do is I would attach that onto maybe a firewall, the likes of OpenSense or pfSense, etc., and then just use that as the main WAN interface going out into the infrastructure. Any questions? Okay, onto the servers. So we've got our networks, we've got our data center. Next, we're going to create some servers in relation to the infrastructure. First off, I'm going to create a Bastion server. So here, give it a name. We're going to tell it that it's going to go into the data center ID. So here, I'm taking the value of the unique identifier which has been created when the data center was created. So we'll be able to pass variables down the chain in relation to the creation of those assets or environments, variables, etc. as well. It's going to have one core, it's going to have a gig of RAM, it's going to use the AMD Opteron, it's going to go into availability zone 1. So again, quite easily, these types of structure can be applied to other infrastructure services which have the same type of availability zones, let's say for AWS, etc. as well. So it's quite common across the different providers out there. We're going to create a volume. This is going to be a system volume, which is going to be the boot disk, obviously. We'll use the image name, so it's back to the image alias, which was that CentOS version. And we'll then pass the console password into the image as well. So this will also inject the relevant SSH keys and also the password for root access for that system. Define a size, 200 gigs, can be using SSD, and again, it's going to use the auto availability zone based on the data center which has been spun out. Party SSH keys, and on the other side there, we can see the network interface card which has been created. Define that as public, so it's going to be the public network interface card. We'll pick up DHCP as well, and then we're also setting some firewall rules in relation to the network interface card which has been created. So it's at creation time, we're locking that down in relation to access to the Bastion server. And we can define also the source IP address based on the source destination in relation to access to that system. Next, what I'm going to do is I'm going to configure some routing. And I'm using something else from Terraform called the remote exec. So that allows you to execute commands remotely into the system that you're provisioning. So here what I'm going to do is set up some IP forwarding and then set some command rules on the firewall in relation to NATing. So I can then use this Bastion server to pass network traffic from one network card to the other in relation to the relevant access. And then lastly, I've got a connection type, how I actually connect into that system using SSH and the very user which I'm going to access into that system as well. So this is the access authentication into the system to remotely execute the relevant commands to set up the NAT forwarding rules. So we have our network. We have a single server, which is now the Bastion or jump server. What we'll also do is create that secondary NIC, which will be used for the private networking, which for the other systems which I'm about to create. So here what I'm going to do is add a new NIC, which is the gateway NIC. This is on the private network, and it'll be used for private traffic only. So I'm doing this example, I'm just going to create a web server, similar to what I did with the Bastion. I'm creating the node, the name is node 1. It depends on is a really good Terraform technique, so you can actually wait for a resource to be built and ready before you proceed to the next stages. So here what I'm saying is that I want to make sure that my gateway NIC has been created before I start creating my web server for the rest of the infrastructure. So it's a method of making sure that all the relevant sets are there before you start moving forward in the Terraform script. So here this the web server is called node 1, 4 cores, 8 gigs of RAM. We're going to zone 1, and for this CPU we're using Intel for the system. We're also going to create a volume, again using the CentOS image based on the image alias, and also the password we're using for the configuration. And there also you have the size in relation to disk size, disk type, and availability zones as well. This NIC on the private network is going to use DHCP, but we also need to set the right route. So as it starts looking for sending data, it needs to go to that Bastion server to send its data out onto the network by using the NAT forwarding rules. So with that, what we do is we install the relevant default route. So we're changing the route of the server, the network route. We're adding the default gateway to use the gateway NIC. And then what we're doing, we're also modifying the resolve.conf by echoing the name server into the resolve.conf file. Yeah, so we know the right route in which it needs to go out. And then lastly, I'm again using the remote exec to actually just install some packages in relation to the web server, starting up some relevant services, etc. as well. I'm using remote exec here, but I could be using other technologies. So I could be using Ansible, I could be using Puppet Chef, I could be using Salt from SaltStack. So there's ways in which I can utilize Terraform by executing remote code internally inside that infrastructure. And then lastly, I'm setting up the relevant connection for that private connection out onto the Bastion server. So once I've got my files created, it's a matter of then going through the various stages to create this environment. So I'll use the Terraform init, which will basically initialize Terraform, grab the relevant plugins that I want to use for my configuration file. So in this case, it will be the ProfitBricks provider. Then I'll do a plan just to make sure that what it's going to build out is correct based on my specifications. And then I can apply that plan. So it will then go out, build out the infrastructure for me, and then come back. This is really visually what it will look like. So this is the Bastion Server. This is the private network you can see in orange. So all traffic is routed directly to this. You have a forward rule which basically sends out onto the internet. So that's really what that would look like. There's also the show command, so you can show basically what you built. So it will take out your state file and present back what it's going to build based on that plan. And you can also graph dependencies as well. So you can see visually how dependencies map in relation to the resources which you created. And I'll show you that shortly as well. Stop there for a minute. Any questions? Yeah.
Is that automatically created?
Which one? This one?
Display, yeah.
This is the INOS Enterprise User Interface. So this is what we would typically use. So with AWS, you have lines based on instances or EC2 instances you created. The INOS Enterprise Cloud has a graphical interface that you can visually see, or you can use command line using the APIs. So the script will build this. This is what we visually will see using our user interface. So it's not quite Terraform user interface, but it's what we use for our technology. Visually, what you'll see is something like that for Terraform, yeah? Dependency using Terraform graph, you dot out with a PNG. This is what the PNG looks like based on your resources, dependency trees, etc. If that makes more sense, yeah? Yeah.
Can you modify your Terraform configs with this interface?
To use?
You said it's created from your declarations.
Yep.
But can you modify your declarations from this interface?
From this interface, no. So this is the INOS Enterprise Cloud user interface. We can't, I guess, retrofit back into Terraform using this interface. But you can also do is modify your environment. So Terraform has the ability to import additional changes that you may have made. So this is the infrastructure it's built. If I go in and maybe create a server on here and I create some networking links, Terraform's not aware of it. So if I do a Terraform plan again, what it will do, it will destroy that node I've created. So I need a way in which I can extract the information I've got there and push it back into Terraform. So Terraform has the ability to do that. It's not an automated process. You've got to modify based on what you've created. So it's not great. So really, you should be using, once you use Terraform, use Terraform. Don't go outside the boundaries and start adding things into your environment. Yeah, just stick into Terraform and stay there. Make sense? Yeah. Okay, any other questions? Is that straightforward in relation to the structure and values and variables? Yeah? Okay, good. Okay, so we talked about dependencies, what it's going to look like. So you can see here the provider, we can see the data center. From there, we can see the LANs we've created. We also have the network interface card there in the middle. And then we can see the relevant servers which are being created as well. So although it's not as pretty as our user interface, you do get some dependency graph and tree in relation to what's being created. Okay, what I'm going to do now is just give you, I guess, a live demonstration really of building out this environment. So this is a production grade deployment of WordPress. So we'll have a firewall, we'll have a load balancer. There's a Bastion server here, which has got various links into all the systems, as well as two different zones. So we've got WordPress, Redis, MariaDB at the top. It's using an FS server as well. And we have the two availability zones. So this is what we're going to build out with the demonstration itself. And I'll just quickly show you, I guess, what that sort of looks like. Let's open the right folder. That's better. Okay, so hopefully you can see this okay. So what I do with my scripts is I normally break things down. So I'll define and declare my infrastructure, I'll declare maybe some variable sets, and then I'll go into the various elements of the architecture that I want to build out. So I'll have the infrastructure components, I'll have maybe WordPress, MariaDB, Redis in relation to those. So I can strip down. So if there's a change within a certain component element, it's very easy to modify that and then roll that back out into the environment quite easily. Where if you create just one long TF file, then you've got to go through the whole thing. Yeah. So we're just making it easy to consume. So I've got my variables, which is going to be my password to get into the INOS Enterprise Cloud, as well as the various certification key, etc. as well, which I won't show you because it's obviously private. I'll show you the DC. So if we look at the DC TF file, we've got the Profit Bricks provider at the top. We've got references to other variables I'm going to set. So this is going to be my location. Again, I'm using CentOS, my name server, my paths, and then beneath that I'm start creating the virtual data center, which we saw initially on the slides. We've then got some LANs I'm creating. So if you go back to the actual picture here, there's 10 networks that are being created. You could say, well, that's actually, maybe more than I need, but what I'm doing with this example is I'm actually extrapolating all the relevant security points. So to get into the likes of the Redis server or the MariaDB, you've got to go into quite a few layers to get there if you do hack inside the system itself. So for security purposes, it's ideal. So you starts defining the LAN. So we've got the public LAN, and then we're going to go from the firewall to the Nginx server, Bastion to Telnet. And again, it's a matter of just giving those a name and declaring whether or not they're public or private. So we've got quite a few there, as I mentioned. There's 10 of them. And then lastly, I've got an IP address, which would be associated into the firewall server itself. Then I'll declare my infrastructure, what that looks like. So I've got my firewall server, number of cores, the family it's being used. Again, the network connectivity, so my network points I'm adding in there as well. And then my Bastion server and so on. So you can see here I'm starting to build out the key infrastructure components that I need, and then I'll move on to the next elements, which will be WordPress. So under WordPress, I've got my 2 servers, one in zone 1 and the other one in zone 2, which is there. And then the relevant volumes which are being created, network interface cards, etc. as well. And the same for Redis and same for MariaDB. So once I have all those, I can start building out and looking at the plan in relation to that deployment. So I have recorded a video, but we'll do this live, and we'll see how this goes. I like looking for live systems and see if I can break them. So fingers crossed. So in here, this is the live system. This has got my relevant files that I've created for the Terraform scripts. You can see there the Terraform executable. So initially what I do is I do a Terraform init. What this will do is pull down the relevant plugin for the deployment for this configuration. Because I've deleted the original plugin which was there, I'm just showing you that process. So it's a one-off. If I did it again, it would need to pull it down because it's already there on the system. So once I've got the plugin ready and Terraform's ready to go, I can then go out and do a plan. So this will read the relevant configuration I've got, and if I scroll up, you can see what's going to be created based on that those files which I've got. So my LANs, quite a few, and then IP, data center, etc. as well. So this is the start of the plan. So it'll start creating the data center, the network LANs, and then the relevant servers that are required for the configuration.
Is that in order?
It is in order, yeah, based on those numbering. So I use numbering with my TF files. So as it processes them, it will go from number type, yeah, basically. So it'll go that order, so I can control it that way. Same as if you would do, if you're doing Kubernetes and YAML, if you number them accordingly, then the YAML execution will go on numbered ordered. You could do as well, yeah.
What was that? I'm sorry.
So you can actually control it through dependencies. That depends on, which I showed you. You could use that as a method of ordering as well. Thank you. Okay, so we have the plan, and now it's a matter of just applying the plan itself and producing out the infrastructure. If I show you the INOS Enterprise user interface, so again, different providers will have different user interfaces that you'll see, but what we will see here is that data center being created, and we'll see some progress in relation to what's been spun out as well. So we'll do Terraform apply. Again, it's just validating the configuration and saving the relevant output so I can use that for further declarations. So now we're going out. So we're starting to create the relevant IP block based on the requirements that I have for this environment. It's going to build out the data center, and it's already started creating that. And now it's going to start creating the relevant LANs or networks inside the data center as well. So if I go back to my user interface, I should see this WordPress environment, which will be probably down the end. There we go. So we can see that now building out. And it's starting to populate the environment for me based on the build of, so if I just move that, we'll see the process. So to build out this environment, it takes around about 7 to 10 minutes roughly to build out the whole thing in relation to WordPress. If I was to do that in the UI, I mean, I use this UI on a daily basis, I'm quite quick, but you know, if I want to build it out, I could quite easily make a mistake. So really the benefit of Terraform is that you automate that process, removing mistakes or errors in the infrastructure, which, you know, if you're doing development, you'll probably see that as you go through and say, oh, this Redis server's not responding because the network's not connected, yada, yada, yada. Okay, so this is build out, and again, I can just refresh my user interface. I should see, you know, more systems come in there, etc. as well. So it will build out everything for me. The templates, the dependencies, the whole configuration will be there. As I said, you know, after about 10 minutes, you've got production-ready version of WordPress ready for you to go. And I can build it the same over and over again, you know, based on the specifications, etc. as well. And having, I guess, the configuration files is one thing. It's then thinking about how you manage those going forward on a life cycle. And this is really where CICD comes into better effect, because, you know, you can put those up into Git, keep a version history of what the relevant changes are in your configuration, pull that down, you know, using Jenkins or CloudBees or whatever, you know, the automation engine that you want to push out into Terraform, and then run the script that way. So it's quite easy to build the whole life cycle, you know, based on your development requirements. It doesn't need to be just infrastructure. You can wind in, you know, other applications in there as well, or, you know, other types, things like Kubernetes clusters, etc. Okay. So just a refresh. Okay, see more stuff coming in. Any other questions while this is building? Yeah.
The Terraform files, the two quoted parameters out to the resource, what are they? Are they in a specific order? Have you defined all of them yourself?
The two, try and get an example. Yeah. Oops. Sorry. An example here?
Yeah, so Profit Brick Server and then Bastion, is that something that you defined yourself, or is that?
Yeah, so the Profit Brick Server is a provider inside the module which we're using that will have certain requirements. So there'll be a requirement to put in the name of the server. You can't omit it, as well as number of cores, number of RAM, CPU, etc. as well. So those are required elements inside that resource type that must be declared, but it doesn't matter what order they're in, as long as they're declared.
And Bastion is just a type of server?
It's just a type of server, jump server, or whatever you want to be. Yeah. And this Profitbrick server needs a volume, so you can't just deploy a headless server without any storage or network. They've got to be declared at the same time. Just the way in which our provider works. Some other providers may be different, but just see how it's going, still going. Okay, and just do another refresh. Okay, starting to build out more stuff.
So you mentioned briefly you could use something like chef or Ansible or something instead of the exec. Would that just be a case of build up your playbook or your recipe and then can Terraform pass that along?
Yeah, so you could use remote exec again to fire out a remote command, which will then bring out the Ansible configuration that you're trying to do. Yeah, I think there's also some modules you can pull in for those as well. I believe there is a Ansible module. Yeah, we normally use like Salt for other applications that we build as well from Salt Stack. That's quite easy to build into. Yeah, directly into that Terraform. Any other questions at all? Straightforward-ish? Yeah? Cool. I'll let that keep building, and then we'll see what it looks like at the end, or I could switch to the video to watch the end bit, and then we can just finish the final slides. Yeah, it'll take a little while. We can all switch back afterwards. Okay, so I'll jump in here. So what we're seeing is the environment being built out. We'll see the networks that have been created. This should be almost complete, which it has. So there was an issue on this build in particular. It missed out 3 network interface cards because a dependency wasn't met. So I just rerun it again, and the final 3 were added into the configuration. What you'll see is the environment being built out, and then I need to manually move them around so they're visually pretty, so I can see where things are. But yeah, these are all built out relevant networks, and then it's a matter of just moving things around so you can see them in the user interface if you want to see that. Obviously, the systems are built. Cool, okay. That was the video. This sort of finishes and off it goes. I'll switch back to the presentation. Okay, I've also got some links, which these slides are available to you, after the event, etc. Just some interesting places to go for more information around Terraform. So you have the direct links into the Terraform providers, list of providers there. Profitbrick's obviously being one of them. Some information how we use Terraform, the likes of Salt Stack as well. So if you want to see how we look at the application deployment along with the infrastructure, then that's quite a good link to go to. And then also, if you're into development, we have our provider available on GitHub, which you can then use and get more information on the provider, the structures, etc. as well. And then lastly, a bit of a set, because obviously it's for INOS. We do have trials available, £500 credit for 30 days, where you can build out and use our environment if you want to as well. I think the biggest, selling point of our infrastructure over the other vendors is that you're getting dedicated resources, CPU, memory. They're not shared resources, they're dedicated to what you deploy. So you'll always get that consistent performance metrics in relation to what you're using as well. And as you saw from the UI, it's extremely easy to use if you want to drag, drop things around or build it with Terraform as well. Okay, with that, that's all I have. If there's any more questions, happy to answer those. We'll see how our build is going. It's finished. Cool. There's no errors by the looks of it either. There was. Cool. Okay, yeah, so we have some network interface cards which are not there yet because of some dependencies. So it's a matter of just going through, reapply them. Yeah, I've got purposely put it there to show the errors. So there's some dependencies which weren't met, so they timed out on creation. What will happen now is that these will create. It should be quite quick because there's only 4 or 5 network interface cards to create. And then we'll see that. There's obviously logs there as well, so you can look at the state file to get the idea of what failed. But we'll see those, what's that, 2 LANs and 4 NICs, which were to be created. Yeah. So 22 seconds, and the other one should be fairly quick as well. That's the last one. Oh, still one. WordPress, Nginx. Okay. As I say, it's nice doing a live demo because you can guaranteed it won't work first time. And then what we'll see is obviously the servers which have been built, and then it's just a matter of just moving those around based on our requirements that we have, etc. as well. I'll reapply, see if that fixes it. Cool. If there's no more questions, thank you for your time. Hope you found it informative. And yeah, just start playing around with Terraform, making good use of the code, really. Cool. Thank you.